All of us are doing great. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. In this particular discussion, I'm going to look at a second part of the types of dispersions. Now, in our first video, I had mentioned the concept of a range and basically said that we had already defined this particular concept for a specific distribution as the difference between the largest value minus the smallest value given in this particular case as such. So I decided that we can give this one in terms of an algebraic representation, whereby this is going to be given as a range is equivalent to L minus S, L for largest and S for smallest value in that particular case. Now there are specific formula which are given in trying to give a range for grouped data, which are basically mentioned that we can have a range given in terms of the UCLK minus LCL, of course that one given as 1 as such. In this case, I mentioned that this basically represents the upper class limit of the last class. In a group data, upper class limit of the last class. Of course, this is going to be, just give it in summary form. And I said that this is going to represent of course, the lower class limit of the first class given as such. So this is going to give us, for group data, this is going to give us the difference between the largest and the smallest value given in this particular case. Now for data which has been given in terms of a class mark, we can give the concept of range, as we said, in terms of the difference between xk or x sub k minus x1 given as such, whereby xk is the class mark of the last class and x sub 1 is given as the class mark of the first class given as such. So this is going to give us a summary of the concept of a range. And of course, we said there are other measures of dispersion which we are going to look at apart from range, and they are going to be given in that particular order. And therefore, I'm going to mention them given in that specific order. So apart from range, which we have said, so there's what we refer to as range and relative range. And we're going to look at the concept of relative range in this particular video. But in this case, we're going also to look at another measure of dispersion. So this is going to be types of measures of dispersion. We're going to look at another measure of dispersion that we refer to as the quartile deviation, and this is going to be quartile deviation. And of course, in that respect, we shall look at the coefficients of quartile deviation. The coefficients of a quartile deviation, just give it them in this particular order. I presume we're going to understand it from that particular case. And of course, we shall look at another measure which we refer to as the mean deviation and the coefficients of the mean deviation. Coefficiency of the mean deviation. And lastly, we shall look at what we refer to as the standard deviation and coefficients of variation. The standard deviation and coefficients of variation given in that particular order. So in this case, these are going to constitute the various types of measures of dispersion which we have discussed now. Apart from the range which I have given in the particular detailed form, of course, we're going to look at other aspects of the measures of types of measures of dispersion given in that particular case. Now, so at the side, of course, we can give range in particular ways, which of course I've given in terms of a formula or representation, which of course did in the initial part of this specific video. Now, in this case as well, we can give this concept of a range, as I said, the largest value minus the smallest value. And in that specific respect, we are going to describe this concept of a relative range using algebraic representation, or in terms of this formula. So I'm going to have relative range represented as such. And this is going to be the difference, or the ratio between the difference of the smallest and the largest value and their sum given as such. But we have defined the concept of range from our introductory part as the difference between the largest and the smallest value. Therefore, we are going to substitute our numerator in this specific ratio to represent the concept of range, and therefore a relative range is going to be given as a ratio between range and the average between the largest and smallest value given in that particular order. Now, suppose we give an example whereby we are given some specific values. So suppose we have been given a range or a relative range of, we said this is going to be a ratio, so of 0.25 and a range of 4.0. Now, if we are asked to find the specific, of course, values of the largest and the smallest value given this specific values for range and the relative range, then therefore we can compute the remaining, of course, set of values by trying to, of course, trying to find a relationship between the two or doing direct substitution in this particular formula. So I've said that relative range is given as the ratio between the difference between the largest and the smallest value, and in this case, this is going to be over of course, the sum of the largest and the smallest value given in that case. But we had said that a range can be given as the largest minus the smallest value, and that's going to form our numerator for description of this specific ratio for this second case. Now we're going to use this relationship which I've given below from a specific set of data whereby we have been given relative range as 0.25, which is a ratio, and of course we have been given a range given as 4. So therefore we're going to have this 0.25 as our relative range is equivalent to 4 all over the largest plus the smallest value given as such. And in this case, this is going to be our first scenario, and then we can have this one as a range which is going to be 4 is given as the largest minus the smallest value. That's going to form, let's refer to this one as our second, of course, relationship. This is going to be our first relationship given as such. And as well, we can give our third relationship whereby we have been told that basically this, or rather from our first relationship, we can be able to do a specific equation in that case by doing a simplification of this one and giving it in terms of L plus S is equivalent to 4 divided by 0.25. So in this case, what I've done a cross multiplication whereby I'm multiplying this one by this. So this one, given this one is just the same as over 1. So therefore, we're going to have 4 times 1 given as 4. And then L plus S into 2.5. So we can do a division over this 2.5 in order to have this specific, of course, variables for L and S, this left side of the equation. And therefore, this is going to give us a variation of this equation over L plus S is equivalent to 16. So therefore, let me name this one as our, of course, relationship number 3. Therefore, for us to find the largest and the smallest value, we're going to consider this specific equation and this one, and they're going to give us a relationship for this particular case. So perhaps I can do away with this so that we can use the space. So we have L minus S equivalent to 4, and then we have L plus S is equivalent to 16. So in this particular case, we can even do a rearrangement for this one. So L is equivalent to 4 plus S. So doing a substitution for L in this case, we are going to have this one given as 4 plus S. So this is going to be S and not 5. So 4 plus S plus another S is equivalent to 16. So 4 plus 2S is equivalent to 16. So 2S is equivalent to 16 minus 4. 2S is equivalent to 12. Therefore, our S in this particular case is going to be given as 6, which is the smallest value. Now, in this case, if we have this particular relationship whereby L minus our S is 6 is equivalent to 4. So L is equivalent to 6 plus 4, which is equivalent to 10. So our largest value is equivalent to 10, our smallest value is equivalent to 6. The difference between the largest and the smallest value is going to give us our range, which is equivalent to 4. And therefore, from this particular range, we can be able to compute the relative range given in that particular case. Now, that's going to be our first, of course, aspect of the types of measures of dispersions, which we have looked in terms of range and relative range. Now, in our next discussion, we're going to look at other various types of measures of dispersions in terms of perhaps a simple example, and that is going to assist us do various evaluation that we come by in our various discussions or subsequent discussions. So that is it for now, guys. Bye, God bless you. Catch us in our next video.